Hello and welcome. The part 1 of this video, I'm going to link it right now. If you've not seen it already, please go see it. In this case, we will be looking at modulus functions. However, we're looking at where the modulus carries a negative symbol. Okay, so we will just look at the steps in doing this, and the first one is to sketch the line y equals to x. The next one is to sketch y equals to the modulus of x. The third one is to sketch y equals to minus the modulus of x. Okay, let's get cracking. For y equals to x, I think that's very easy. We've been doing that a while now. We simply draw a line across those points where x equals to y. And be careful to ensure that your line passes through the points that are intended. Usually students just draw it. They don't take particular interest in where it crosses. This is very important. So you can see that when x is 1, right there, if you trace it, y is also 1. Okay, and now, so this is 1 here, this will also be 1. When x is 2 here, y is also 2. So you can see that I've carefully chosen those points. Okay, it's the same thing here. X is minus 1, y is minus 1, x is minus 2, y is minus 2, and so on and so forth. Okay, so level 1 done. For this one, we have to bounce this place back up. All right, so let's quickly do that. Okay, so we draw this up that way. Let's end there. Okay. Because I will clear the down part, it's better to just draw this so that it overlays that one, and then I can clear out what I have here. Okay, so that is y equals to modulus of x. Of course, that part here should end around that place. Okay, so that's what we have. Now, how do we draw this? We simply reflect these two parts in the x-axis. Okay, because what this is telling us is that every value of x, okay, which normally, because of the modulus function, should turn out positive, will now be negative. So, which means your value of y. Okay, so why are we going to, because what we are going to do is this. We're going to drop this down the axis that way, and then drop this back down the axis. Yeah, and that is done. So why has that happened? It's because normally at this stage, y is always going to be positive. But then with the minus now right there in front, it ensures that every positive y is now negative. And that is why you don't have anything to do with the positive y here. They are all congregated in the negative y axis. So that's how that one is sketched. Next example. All right, so this is the next example. Let's look at the steps. First, we are going to plot y equals to x. Next, we are going to consider y equals to the modulus of x. Next, we are going to consider y equals to, if you like, you could consider x minus 3. And then next, we will reflect it in the x-axis to give us minus x minus 3. And then the last part will be to bring it up 1 unit so that we have minus x minus 3 plus 1. Okay, we better get cracking. I'm going to jump over to this place because I've taken so much of the first one that we already know it. So the first one goes this way. Let's end there, and the next one we go from there this way. That concludes y equals to the modulus of x. Next, I will move it positively 3 units. If there is a negative here, remember it's a positive x movement. So it's a positive movement to the right 3 units. Okay? Plus 3 units. That's what this is. Okay? let me just do that. Okay, so it's a positive 3 units movement on the x-axis, on the horizontal axis. So let's do that. 1, 2, 3. It's moved positively right there. At this juncture, it might be good to note that this will be 3. And this will also be 3. How do I know? At this point, we know y is 0, so we can make y to be 0 here. So we have 0 equals to x minus 3, okay? How to solve this is to say minus 0 equals to x minus 3, or you say 0 equals to x minus 3. Now, of course, this is just trivial. Minus 0 is 0. So both equations give us x equals to 3. That's why we have this. But for this one, we make x to be 0, because this is the y-axis. X is always 0 there. So if we make x 0 in this equation, we have y to be equal to the modulus of minus 3, which is simply equal to 3. Okay, and that is why that is 3. Now that that is done, we are going to consider doing Roman figure 4, and that is we flip it in the x-axis because of that minus. That's what that minus does. Now because this portion here goes through 3, the other portion will also go through minus 3 right there. Okay, but we must also flip this. And then we have to be careful where it goes through. So you can see that it goes through 5 right there. So that position there is 5. And this one, I think it's 8, most likely, because this is 4, 5, 6, 7, 8. So now we know. So bring it down. And then we expect it to go through 5 and then 8, isn't it? Okay, so to do this other part, if you look at it, you see that there are 1, 2, 3, 4, 5 gaps there. So you're just going to imagine that it's also going to go through 1, 2, 3, 4, 5 gaps there. And that's the mark we're bringing it down to. Okay, so let's do that. Just bring it down that way. Okay. So that's all for this particular stage. Now we raise it up 1 unit because it says +1 right there. So we raise it up 1 unit. Let's see how that goes. So this one we go up 1 unit and come to that. And this one we also go up 1 unit and come to that. Alrighty, so this one is now at 1. We now have to figure out what this is. And we know that this will be 4. Okay, so at this point here, we know that x is 0. So we make x 0 in this equation. If that place is 0 there, right, we have minus 3 plus 1, which gives us minus 3 plus 1, which gives us minus 2. So that's why we know that this will be minus 2. Okay. Okay, so for this particular one, you see it's a bit complicated because the x here now has a coefficient of 2, no longer 1. So let's look at the steps we might use to help us to sketch this. The first one, we sketch y equals to 2x minus 1. And then we go on to use the modulus. So we sketch y equals to modulus of 2x minus 1. And then we flip it with the negative. So the third one will be to sketch y equals to minus 2x minus 1. And then the last one we add 5 so that we have y equals to 5 minus 2x minus 1. Okay, so for the first one, let's get cracking. We need the intercepts. So we need, intercepts simply means where the line crosses the x and the y-axis. So wherever it crosses the x-axis, we know y is 0. So let's make y 0. We have 0 equals to 2x minus 1, which gives us x to be half. So x is 0.5 if you like. The other one, we make x 0. If we make x 0 here, we get y to be minus 1. Okay, so those are 2 points. Really good. We can choose this point here for x to be half, and they say y is 0, so it should cross that point. Also, when x is 0, y is negative 1, that will be that point, negative 1. This is 0.5. Okay, so obviously, you see that our line most likely will cross this place. So it will cross 1 unit here, 2 units on the y, most likely. And we can just extend that. Okay. So let's do that. We extend it 1 unit on the x, 2 units on the y, 1 unit on the x, 2 units on the y. And then we bring it here also 1 unit on the x, 2 units on the y, 1 unit on the x, 2 units on the y, 1 unit on the x, 2 units on the y. Okay, so if you look at it, you will see that 1 unit here, 2 units y, 1 unit, 2 units, 1 unit, 2 units. That's what I've done. 1 unit, 2 units, 1 unit, 2 units, 1 unit, 2 units. Okay, so we are done with this one. What we want to do now is to bounce it back up, because that says everything will be strictly positive. So this part that is below the line, we don't need it. We need to bounce it back up. So let's do that. Now what that means is that this one will maintain the point, but this one that crosses to minus 1 will cross through 1 now. If you bounce it back up, it should cross through 1. Okay, and then remember it's 1 on the x, 2 on the y. So 1, 2. So that's that point there. And then from that point, 1, 2, that's that point there. Well, hopefully that is clear to you. So we bounce it back up like that, if you like. Then it might be good to draw another one for this one. Just want to make sure that they completely overlap. Yeah, so that you have that. And then I can take out this particular line. Good. Now, this particular one is done. The third one is to flip it in the x-axis because of that minus. So we're going to flip it, which means our line is coming back down this way. Okay, remember 1, 2, 1, 2, 1, 2. Okay, it's coming back down. So let's bring it back down right there. Yep, it's going to go through that point 1, 2, 1, 2 if we like. So the next thing we want to do is to flip this side so that it comes downwards like that. Now be very careful the way you choose your points. So for this point now, we know we are going to choose this one. Okay, so you can see that all I've done is to mirror it. 1 space before the x, 1 space after. So for this point now, you see that we have 3 spaces before the x, 3 spaces after. So it's going to be here. And then here is 1, 2, 3, 4, 5. 5 spaces before, 1, 2, 3, 4, 5. 5 spaces after. So it's going to come here. Now that we have places that will cross through, we simply extend it. And that's what we have. Now this one is done. That's the next one. Now we just need to raise it 5 units up. Let's do that. This one is at 0, so it's going to go 1, 2, 3, 4, 5. So the new points will be here. Okay, I'm just going to clean these ones. Now let's consider all other points. This one is at -1 here. If you raise it up, it's going to be at 4. That will be there. This one here is also at -1. Now it will be at 4 right there. This one is at -3. If you raise it up 5 units, it's going to be at 2. Okay, this one is at 5, -5. Now it will be at 0. All right. This one is at -3. It's going to be at 2. This one is at, well, -1, 2, 3, 4, 5, 6, 7. So it's now going to be at -2 right there, because you have risen up 5 units. Okay, we have the points we need. Let's raise it up now. Okay, so that's it. That's what we need. It's now done. All right, so this is your graph of y equals to 5 minus 2x minus 1. This place will be 3 and this place will be -2. Now, to be sure that we are correct, all we just need to do is to solve this algebraically. So now, to be sure we are correct, especially for these 2 points, all we just need to do is to make y 0. We know that y is 0 at those points, so make y 0 there, and then we solve for x. Now, you will have 2x minus 1 to be equal to 5. Algebraically, this means that 2x minus 1 equals to -5, or 2x minus 1 equals to 5. And after solving, I get x to be -2 or x to be 3, which is exactly what we have there. Well, this concludes this video. I hope it was helpful. If you found it helpful, please remember to subscribe and like. Okay.